Controlling access to files with Linux file system permissions. Today this is going to be a topic for session. Let's start with what are permissions. Linux has basically three base permissions which are read, write and execute. When there is a read permissions on a file or a directory, this means that the user owner or a group owner can view the contents of a file or a directory. Similarly, if there are write permissions on a file or a directory, the user owner or a group owner or others can modify the file or the contents of a folder. If there are executable permissions on a file, this allows a user to execute a file, which basically means that he can execute a script which is in the file. If the executable permissions are set on a directory, one can enter into the directory, which is equal to cd to the directory in Linux. And these are represented by 4, 2, 1 numbers respectively. Now, how the permissions of format of permissions is defined? We completely have four sets. The first set is dedicated to the type of the file, be it a directory file, be it a flat file, or could be a device file or a block file. It could be a link file. So there are multiple types of files. So the first set is for the type of the file. The second set is for user owner as defined in the image if you look at, and the third set is for group owner, and the last set is for others. And this is the numerical table of all the permissions which are in place if you look at, which are with combined with base permissions, or you could have multiple permissions put together and the numbering is defined. Similarly, if you look at execute permissions, which has number 1, W which is write has number 2, WX has 3, read has 4, read and execute has 5, read write 6, read write execute has 7, and if there are no permissions, the corresponding code would be 0. So we would use these codes in further slides to provide permissions to a file or a directory. Now, how do you display the existing permissions of a file? There are two commands. Basically, one is ls-l, which is listing the permissions of a file. ls is list, -l refers to the long list of the file permissions or properties. The ls-l file name would display the file permissions ls-l, and if you provide the directory name beside it, should list the contents of a directory, and ls-ld provides the pattern or the permissions of a directory itself. UMask is one of the important part of the permissions, because this is what defines what permissions a file or a directory should have when it is created. So the default permissions of a file or a directory are defined or decided by UMask value. So different profiles can have different UMask value, and if you want to know the UMask value of a particular user profile, I'm logged in as user root, so I would have UMask value of 022. So forget about the first digit, we will talk about it in a bit. So last 3 digits are 022, which are basic permissions of a root user. Let's say I have a user called lab. Okay, let me create a user. I think it has expired. User add lab, for example. I may switch to user lab and see what are the UMask values that are set for the user. So a regular user has 002 as the UMask value. So this is what defines or decides what type of permissions a file or a directory should inherit or should have when a file or a directory created. Now, how the permission set is defined or decided. It is the subtraction of the umask value from the full set of permissions. For example, if the umask value is 002, the directory will have 775 permissions if a directory is created. If the umask value is 002, the file will have 664. So it is a subtraction of the umask value from the full set of permissions. For a directory, the value is subtracted from 777, whereas if it is a file, it is subtracted from 666. In order to change the umask value, you could simply use umask and the value name that you would like to have. For example, I could change the umask value of the user lab using 022. That should change the umask value. Right? Now, how do you change the existing file or a directory permissions? The syntax is chmod and the code that defines the permissions of a file or a directory and the file name or a directory. So the code can be taken from the code table that we have earlier seen from the earlier slide, and you could use a command called chmod and the code just like 775 or 665 766 to a file or a directory, and this would apply the required permissions specified in the command line. For example, I have one file and few other directories here. Let me create a file called umask file, for example, and this has umask file. This file has 644 permissions because the umask value of the root user is 022, which basically means that if it is subtracted from 666, the result would be 644, which is equal to the permissions I see on a file. If I create a directory ls-ld umask directory, there we go. It has 754 permissions which are extracted from full set of permissions 777, and the umask value 022 is extracted from that. Hence we would have 755. Basically, the umask value is masked from the full set of permissions. That's where we have the default permissions of a file or a directory. And since we are talking about chmod as well, let me change the existing permissions of a file. Let me look at the umask file permissions first. It has 644. One way of changing the permissions is that I could simply use chmod and to whom I would like to change, maybe a user or a group and others as well, right? I would like to add write permissions to all these sections on this file called umask file. There we go, I have added write permissions, and if I want to remove a particular set of permissions from there, I could simply use subtraction symbol. Maybe I would like to remove write permissions from others, and this goes same with the directory as well. I could use multiple set of permissions to add, remove and apply the permissions. For example, chmod, I would like to add, or maybe I would like to make sure that the user has read, write, execute on umask file. It doesn't matter what permissions have been there earlier. You see, read, write, execute permissions. Okay, now sorry about that. Now Now similarly, you have multiple options. You could also use a numerical value to change the permissions of a file. Chmod, maybe I would like to set it to 775 on a directory, umask directory, for example, ls-ld umask directory. Previously umask directory has 755 permissions. Now I have set it to 775. So this, hence the values or the permissions I have applied. Now we come to an important part of the permissions. There are three types of special permissions which make the administrator's tasks more enhanced and easy to manage few things. So special permissions provide an extra security and extra enhancement to the basic permissions which are already in place. So let's talk about the first special permission, which is a SUID, which basically means set user ID, which is numerically termed as 4. And this, if SUID is set on an executable file, it is executed as the owner of the file rather than the one who executed it. As we must have already seen in our previous videos, that if a person has executable permissions on a file or a file, the user will be able to execute that file if there is a script on the file. Let's see, we already have a umask file. Right? This has executable permissions for the user owner. So user will be able to execute this file if there is a script in it. So let's look at one important file of our Linux system. Right? When you look at a file called user bin passwd ls-l, this gives me that this particular file is applied SUID on it. Normally passwd is the command that we use to change one's password, and being an important set of permissions or being an important command to change one's password, it is set as only root can execute this file, because if a user executes this file, he wouldn't be able to execute this file if there is no SUID set on a passwd file. Rather, if he tries to execute, or if one tries to execute as a normal user, the output of the password command would not be effective, as the normal user wouldn't be able to have all the permissions required for the changes the passwd command would like to make. Hence, SUID makes it possible that if anyone tries to execute this passwd command, this would be executed as the user owner of the file. Here we see root being the user owner. If you look at the S, this is what makes the difference from the different many other files that we have looked at so far. So the user set of permissions will have S at the place of executable permissions. When there is a lowercase s, means that there is an executable permissions behind it. And sometimes you would also find that if there is no executable permissions for the user, it would list or it would show us an uppercase s there. So the basic syntax to change or to set an SUID on a file is chmod u, because this is set on a user. So user plus SUID and to a file. And SUID cannot be effective on a directory. And this is how sometimes you would see there is an uppercase S on a file if there are no executable permissions behind it. One note is that you could also use chmod and the number. Instead of u plus s, you could also use number to set the SUID along with the permissions on a file. So previously we have seen that the umask has 4 digits. If you look at the umask value, it has 4 digits. The last 3 digits are related to the base permissions which are being masked, and the first digit is related to the special permissions. So the first special permission, since there is a 0, which basically means that there are no special permissions set. So if we are using 4 here, it is represented to SUID. Okay, so and we have already seen that passability is one of the good examples for SUID. Next, SGID. This is set group ID, which is referenced as number 2. If this is set on a file, and if the file is executable, the file is executed as the group owner of the file rather than the one who executed it. Just like a file that we have seen so far, where the SUID is set. Similarly, on a directory, if there is a SGID on a file, if there is an SGID set, the file is executed as the group owner of the file. And if the SGID is set on a directory, the files and the directories which are under the directory will inherit the group ownership of that directory. So to set an SGID on a file, you could use chmod u plus g, similar to u plus s that we have seen in SUID, and a file name. And this would change the permissions set with an s at the place of x at group owner permission set. Similarly, you could also use u plus g on a directory as well. And also you could use SGID to be set on a file or a directory using a numerical code. For example, 2700 basically means that it sets SGID and provides read write execute to user owner and none permissions to group owner and the others as well, right? And if you want to, for example, let me see, I have a directory called let me create a directory, mkdir SGID directory, for example. Let me create a group as well, finance. Let me look at the existing permissions of the SGID directory, right? It has root and root with 775 permissions. Let me create a file under SGID. Right? Let me look at the permissions as well. SGID file. It has inherited only the existing permissions. Okay, based on the umask value that is already set, the 644 permissions are given, and it has root as the user owner and as well as the group owner. However, it may not be same in everyone's scenario. I'm sorry again. Now, if there is a situation where there is a finance project or a finance group who wants to access all the files and directories which are part of their own directory, and if the similar kind of permissions are set that we have seen just now, which are accessible only to root, finance team would not be able to access the files and directories which are under it. Hence, the SGID would be a big boon for them, where I could use chown command to change the permissions of a directory or change the user owner or a group owner of the file. So I would use chgrp, which basically I'm only changing the group ownership of the file or a directory for now. So finance SGID directory. So let me look at the permissions of that directory. Again, now it has the finance as the group owner, and let me set SGID on this directory, chmod 2755 SGID directory. Now SGID is active on the directory. Now let me create a file under the SGID directory. File. I may look at the file now. There you go. Now the SGID file, which is under SGID directory with finance as the group owner, has inherited the group ownership automatically from its parent directory. So this would be more useful in a common environment where multiple people of the same group wants to access one particular directory of their own team. And hence we get to StickyBit, which is one of the useful and a secure way of accessing files and modifying files. If the StickyBit, which is numbered 1, is set on a directory, only the user owner of the file or a directory can delete it, because this is more secure, where one file is created by one user, and if another user wants to delete it, the StickyBit would block that user from deleting it. So to set a StickyBit on a directory, we would use chmod o+t and the directory name, and also you could use a numerical way, chmod 1755 on a directory. So here the /temp directory would be a good example for this, because by default it has a StickyBit enabled. So let's look at ls-ld tmp. It has T, which is enabled by default, right? So let me create another user by name Sally. Now let me switch to Sally user. Since Sally has executable permissions on a directory, he can get into the directory and create a file called StickyBit. For example, let me look at the permissions. StickyBit. So StickyBit has Sally as the user owner and as the group owner as well, right? Let me set chmod full permissions on this file, right? Which basically means by default anyone can rewrite and execute this file, which means anyone can make modifications, anyone can remove this file, or anyone can add content to this file. Now let me log in as the lab user, and we get to the same directory, and we look at the StickyBit file, and now the Sally or Sally's file with the name StickyBit looks attractive. Now lab user thinks, okay, let me go ahead and delete it. I may try forcefully removing it. Now this gives me a denial error, which basically means that the user lab cannot remove the file which are owned by someone else. The permission operation not permitted, which basically means that the lab user cannot remove or delete someone else's file if there is a StickyBit set on a parent directory. So easy to understand. Great. Now this is where we have seen the set of permissions, how they are applied on a file or a directory, and we have also seen how a umask defines the user owner, group owner, others permissions on a file or a directory, and different types of special permissions, SUID, SGID, and as well as StickyBit, which enhance and provide more security to file or a directory, and which would also enable an administrative tasks more easier. So I hope you are able to understand, and let's catch up with another session in the next video. Thank you for watching.